Hello, my name is Gyuhan Lee. I mostly draw with code, and these are a few works I made before. These may look fine, but I rarely succeed, and in the few cases I do, I find that my failures look better, maybe the ultimate failure. But there is something about failures. This is a video about my work Messy Clock. This work started from a failed study about CCDIK, but also has some interesting failures about using typography with fragment shaders. CCDIK stands for Cyclic Coordinate Descent Inverse Kinematics, whatever that is. CCDIK is a rule that answers the following question. When given an arm with a fixed length and its joints defined by angles, how can an arm reach a given target? Each joint rotates toward a given target, the last joint, the second to last, and the third to last. When these rotations are executed consecutively, the arm reaches the target. This is an algorithm that can be extended to 3D and be used to control 3D models or robot arms. So back to why I started studying this. I had made this video before, and I wanted to control the animation using CCDIK. So I started with this, a two-joint scenario in 2D. And unlike CCDIK, does not account for joints more than 2. I will skip the details about this. And this was the initial implementation of CCDIK in 2D. I extended this to 3D. And it resulted in this sad sample video. I have never shown this in public. After some despair, I remembered that this example reminded me of clock hands. So I had an arm which could point anywhere in space, and for some reason I wanted to make a messy clock. something like that Salvador Dali clock. But to be something like a clock, I needed some typography. In my usual environment, where I mostly draw with fragment shaders, drawing text efficiently is not a trivial task. To illustrate this point, I think some explanation is needed about my working environment. I use fragment shaders a lot, and most of the time, this begins with drawing a rectangle. When a rectangle is drawn, I can start working with something called UV coordinates. When you zoom into an image, there will be tiny pixels, and those pixels will each have unique positions. This is kind of what UV coordinates are. If I want to draw some text in this environment, I could prepare some image of a text that matches the intended size. But preparing the resources would get very tedious. If there were many variations in the size of the text, or there were multiple characters being used. There is a format that addresses all these problems, and they are called MSDF fonts. They are a format made by Victor Klumsky. It would have been wise to learn to use this font, but as always, I settled with a weird solution. These are the files that are used to draw numbers for the clock. They were generated using MSDFgen made by Klumsky, which takes a SVG file as input and makes a MSDF image for a single shape. I prepare multiple SVG files and tile them up so I can reference a specific tile from a single image in shader. This is the file that I use when I want to draw alphabets. I have not yet taken into account kerning, letter sizes, and other data. So some of you might have noticed weird typography in my work. With these files, I am almost ready to draw the numbers for the clock. But there is still a problem. How can I decide where to draw the numbers? Let's say we have a grid like this, and that we want to draw the numbers around the edges. I can prepare an image like this that has a resolution matching the grid size and has values assigned along the edge of the grid. This was kind of how the numbers in these videos were drawn. Now I wanted to bend this clock. There are a lot of ways to draw 3D with code, and one of them is ray marching. The following kind of illustrates how ray marching happens. You can think of this square as a screen that is about to render a 3D scene. As the name suggests, we calculate each rays projected from the screen and into the 3D landscape. When the rays stop, we use the calculations to color the screen. Ray marching was not really needed for the clock, but I used it anyway. As you can see, some simple geometry would have been enough. But ray marching does open a lot of other possibilities. We could repeat them in space for no apparent reason. Twist them. Distort them. Or morph them into other shapes and bend them. And maybe add some super glitchy light. Maybe the right decisions aren't always right, nor the wrong decisions always wrong. I think this holds true for failures as well. Anyways, the early works of Messy Clock were made as a video, and the drawing techniques I used here were not real-time friendly. Why suddenly craving real-time, you may ask? I recently participated in a residency program named Welt, and made a collaborative work using the Messy Clock with Minjae Kim, an artist based in New York who makes furniture. One of the ways we chose to collaborate was to make a functional clock using Raspberry Pi. A tiny computer with lots of pins that you can plug wires into. As a personal work, I made a simple Android app as well, so real-time rendering was needed. I've mentioned before that Many of my works start from the UV coordinates of a rectangle. But drawing everything on top of a rectangle is not always efficient in terms of performance. So on this desktop version of Messy Clock, we draw tiny rectangles on the areas where drawing is actually needed. And then we use the UV coordinates of each rectangles to draw the actual shapes. You can see that most of the time, I don't know what is the right way to do stuff. Individually, this could be seen as failures. But when failures are stacked over time, they add up to something unique. I am pretty exhausted now, so I will show you some more random images and videos from the residency program mentioned earlier.
One Mississippi, two Mississippi, three Mississippi. The road visitor number 1391. Hi, this is Welt. I will start printing now. Printing has finished. Have a good one.
Thank you for listening. This was Check on Hyuk.